This takes us to an interesting question, which you will see now. And this is the question. When a polynomial is divided by x minus 1, the remainder is 5. The same polynomial is divided by x minus 2, the remainder is 7. You have to find the remainder when the polynomial is divided by x minus 1 into x minus 2. अभी थोड़ी देर पहले हमने इस क्वेश्चन को पिछली स्लाइड पिछले क्वेश्चन में भी समझाया था कैसे करना है. बिल्कुल सेम वही चीज, शुरुआत वही से ही होगी जहां से हमने चालू रोका था. डिवीजन एल्गोरिथम. Dividend is equals to divisor into quotient plus remainder, that is function of x will be equals to some divisor. In case 1, divisor is x minus 1. In case 2, the divisor is x minus 2. So we have to apply it, and let when the divisor is x minus 1, the quotient is qx, means qx is the quotient, and when the divisor is x minus 2, the quotient is kx. So we say that the function of x becomes equals to x minus 1 into qx plus remainder is already given 5. This is simple division algorithm. In case you are finding it difficult as to how we are getting it, a small quick thing which can be told to you. Suppose 13 actually is divided by, say, a number 3. 3 fours are 12. We will be getting a remainder 1. What does it say? If this is the case, then we will say 13 will be equals to, yes, divisor into quotient plus remainder. So this is what we are actually saying. Here the divisor was 3, the quotient was 4, the remainder is 1. What we have to understand is that the degree of the, again I am repeating, the degree of the remainder, earlier we have already talked a lot about it, the degree of the remainder has to be smaller than the degree of the divisor. Here it is x minus 1, then this has to be a constant value or a constant, it has to be a constant. Okay. So all things done, then we know that when we substitute x minus 1 is equals to 0, we'll get x equals to 1. Remainder theorem, substitute 1, we know f1 is equals to 5. So similarly, we know f2 is equals to 7. These are the two things which are known to us. What? When we substitute 1, we get 5. We know when we substitute 2 in the dividend, then the remainder is 7. We do not know what form of dividend is, but these two things are pretty well known to us. So basically, we are more concerned with this thing, which we will write down and we'll use it later on. Always will be true, and this function attains the value 7 when 2 is the value of the variable. Now, interesting thing is that as we move ahead, and we say that it is divided by x minus 1 into x minus 2. In case we are dividing it by x minus 1 into x minus 2, we are essentially saying that we are dividing it x square minus 3x plus 2, which is of a degree 2. So the remainder will be 1 degree smaller. If it exists, a can be 0, which we will find out whether it is or not, and b can also be 0, but we have to write down this will be the remainder in case this is the divisor. So we move ahead and then we write it down. When it is divided by x minus 5, x minus 2, the remainder will be of the form ax plus b. Substitute the value 1 in this equation. So in case you substitute 1 here, this 1 minus 1 will be 0. So we will get, we already have the value of f1, so we will get 5 will be equals to, this part will be 0, a multiplied by 1 plus b. So a plus b will become equals to 5. This is what I am saying. And then similarly, when we substitute 2, we will get 2a plus b is equals to 7. Simply substitute 2. Again, this particular part, the second part will become equals to 0. This part will become equals to 0 now. And then we will get 2a plus b. Why? Because we have substituted 2 here, 2a plus b, and we already know the value of function at x is equals to 2 is 7. So then, when this is done, we have got linear equation with two variables a and b. We can find out the value. A will be 2, b will be 3, and the final answer to this question will be 2x plus 3 will be the remainder, and that is all.